Synthetic division is a pretty convenient way to divide a polynomial by a specific type of linear term. If you aren't familiar with synthetic division, when you can use it, or how to apply it, this is exactly the video you want to be watching because I'm going to answer all those questions in this video. If that's something that you want some more help on, or just to see another practice problem, do an example, anything like that, you're definitely going to want to stick around to the end of this video. And without further ado, let's go ahead and jump right into the problem, and I'll show you what I'm talking about. We're going to use synthetic division to divide 5x cubed plus 18x squared plus 7x minus 6, all divided by x plus 3. So these synthetic division problems so let me first point out, synthetic division method as a whole, it can only be used whenever you're dividing by x plus or minus some number. So it does have to have that very specific form. It can't even have a coefficient in front of the x. It just has to be x plus or minus a number. So all the examples we're going to be going through today fall into that category. And then the other thing you want to kind of keep in mind is basically this polynomial that you're dividing by that x plus or minus a number can basically be any polynomial, any degree polynomial. The process and the steps you're going to go through are going to be the same, whether you have an x to the 100th power here or just an x cubed power here. The only thing that you need to make sure is that you just have x plus or minus some number here. So basically, to set this up, what you want to keep in mind is basically the kind of formula that this is based on is if you have some polynomial divided by x minus k. So that's something to just be careful of. It is x minus k, whereas here we have x plus 3. So what that means is the actual k value here, x plus 3, is actually the same as x minus negative 3. So the k value that we're going to use here is actually negative 3, even though we have x plus 3 right here. So just kind of keep that in mind. That is obviously something that is a little bit weird. It looks opposite of how you might expect it to look, but just be careful about that when you're setting up the problem. So now that we've kind of pointed that out, let's go ahead and get into how to actually set up one of these synthetic division problems. Basically, what you're going to want to do is you're going to basically just set up this little division symbol thing. You're going to make sure that you have your polynomial written from the highest power x term down to the lowest power x term. So here we already have it written, x cubed, x squared, x, and then our constant term. So it's already in descending power of x, which is exactly what we want. Once you've confirmed that it's in that order, you can basically just take the coefficients of each of those terms and write them in this little kind of L-shaped division curve thing. So we're just going to take 5, write it here, 18, write it here, 7, write it here, and then negative 6, write it here. So be careful, make sure the sign does line up with the numbers you write here. And then what we're going to do is we're just going to write our k over here. So we're just going to write negative 3 over here. So this is always going to start out the same way. You're basically just going to start by taking whatever this first number is here, in this case 5, and carry it all the way down to the bottom here. Okay. Then from there, you're going to go diagonal. So you're going to go from 5 to over here, and you're going to write a new number right here. That new number is just going to be whatever this number down here was times your k. So 5 times negative 3 gives us negative 15. So we're going to write that right here. Then once you've done that, you kind of just go down this column now. So now you're just going to add these two numbers. So 18 minus 15, or 18 plus negative 15, is just positive 3. So you're going to write that there. And then you just kind of keep doing the same exact pattern. You're just going to start by carrying your first term down, and then you're going to go diagonal and then down and diagonal and down and diagonal and down until you get to the end. Each diagonal move is going to be a multiplication of whatever this number is times whatever your k value is over here. And each down move is just going to be addition for whatever the two numbers are that are in this column here, and then write the result down here. So next move now is going to be diagonal. So we're going to go 3 times negative 3 gives us negative 9. And then down 7 plus negative 9, which is the same as 7 minus 9, which gives us negative 2. And then -2 times -3 gives us +6. And then -6 plus 6 gives us 0. So now we need to kind of figure out what this actually means. Obviously, we've kind of got these 4 numbers here, but what does that actually tell us about the solution to this division? Because, dividing this polynomial by this polynomial shouldn't get us to like a 4-digit number or anything like that. Like, we need to think about how this actually translates into a polynomial that makes sense as a solution to this long division. Before we jump into that though, if you do have, if you are getting value out of this video, do me a favor, hit that like button down below, just smash that thumbs up button down there. Helps kind of spread this video out to more people, and so we can keep growing the Jake's Math Lessons community and keep crushing it all term long in pre-calc and calculus together. So just hit that like button and we'll carry on here. I'll show you how to kind of finish up this problem. So once you've gotten these numbers all written down here, once you've gotten all the way to your last term and you're done, this is going to kind of translate to a polynomial. So the last number that you have written over here, in this case it's 0, is always going to be your remainder. So since we have a remainder of 0, that's kind of nice. That basically tells us that this polynomial divided by this linear term actually results in a nice even polynomial. We don't have a remainder, so that's kind of nice. Then what you basically have to do is these other remaining numbers are just going to be coefficients of x raised up to some power term. But how do you know where to start? There's kind of 2 ways you could think about it. You could either start from the left and go right, where you know that your first x term is always going to be 1 less than whatever your highest x term was in the polynomial you started with. So in this case, we know that our highest power x is going to be x squared, and the coefficient of that term is going to be +5. And then we're just going to decrease our coefficient, or our power of x, until we kind of use up all these coefficients. So the next one is going to be 3 times x, and then the last one is just going to be -2 with no x with it. The other way to think about it is we could start from right to left, knowing that our farthest right term is just going to be a constant being added or subtracted at the end, and then we're basically just going to add a power of x each time as we go over to the next coefficient. So either way, you should end up at the same thing. And then, like I said, this last one is your remainder. Since we have a remainder of 0, that doesn't really provide anything here, so we can kind of just leave that out. And so we know that this polynomial right here is the result of dividing this polynomial by x plus 3. Well, I hope you found this video helpful. If you did and you want to keep this brain train rolling, you're definitely going to want to go check out that video right there, where I teach you about polynomial long division in general. Synthetic division is great, but you can't always use it, and polynomial long division should help fill in the gaps there.